Science is all about the quest for knowledge, right? Pushing boundaries, making discoveries. But what happens when that quest actually harms the very people it's supposed to help? It's a serious question, and one that has really haunted the field of research for decades.
Okay, let me ask you something and be honest. You'd probably say no, right? Of course not. But what if a scientist, an expert in a white lab coat, insisted? What if they told you it was crucial for an important experiment? Suddenly, that line gets a little blurry, doesn't it?
And here's the thing, this wasn't just some hypothetical question. It actually happened. Back in 1963, Stanley Milgram's infamous obedience experiment showed that ordinary good people could be pushed to do some pretty terrible things, all under the direction of an authority figure. The results absolutely sent shockwaves through the scientific world and helped change the rules of research forever.
So to really get why we have all these ethical rules today, we've got to look back at a time when, well, we didn't. And these stories, they're more than just history lessons. They're chilling reminders of what can happen when science loses its ethical compass. I mean, just imagine this for a second. You're sick, you trust doctors to help you, only to find out years later that you were part of a 40-year experiment. That's exactly what happened in the Tuskegee study. Hundreds of African-American men who had syphilis were deliberately denied a known cure, penicillin, all in the name of science. It's just a profoundly dark chapter in medical history. And the shock from the Tuskegee study was still very real when, bam, another ethical bombshell dropped. This time, it was the Stanford prison experiment. It was a terrifying look at how quickly the lines between right and wrong can just dissolve when you give some people power over others.
And things got out of hand fast. The students assigned to be guards became sadistic and cruel, and the prisoners started having psychological breakdowns. A study that was supposed to last 2 weeks had to be shut down after only 6 days. It was just a frightening glimpse into a darker side of human psychology.
So when you look at this timeline, you can see this incredible story unfold. You can literally draw a line from these moments of harm to the creation of the rules meant to stop them from ever happening again. There's a clear cause and effect.
So, out of all this horror, something had to change. And it did. The scientific community basically said, okay, enough is enough. The result was a whole new set of guidelines, a new framework that put human dignity and safety first and foremost.
First up was the Nuremberg Code, and this was a huge deal. It came directly out of the ashes of World War II, as a direct response to the horrific experiments conducted in Nazi Germany. Its core message was simple, but, believe it or not, revolutionary at the time. Nobody should ever be forced to be part of an experiment. Period. Voluntary consent became non-negotiable.
Then, a few decades later in the US, the Belmont Report came along. It basically took all these big ideas and boiled them down into 3 simple, super powerful principles that are still the bedrock of American research today: respect for persons, beneficence, and justice. You can think of them as the 3 main pillars of ethical science.
Okay, so we have these big principles, but what do they actually mean in practice? Let's start with the biggest one, kind of the golden rule of research ethics.
Beneficence. It's a bit of a fancy word, but the idea behind it is super simple. Do no harm. It means the participant's well-being, both physical and psychological, comes before everything else. If a study's potential risks are bigger than its potential benefits, it's just not going to happen. It's a non-starter. But it goes deeper than just do no harm. It's also about empowering the participant, right? It's about respecting their right to choose and making sure their privacy is protected every single step of the way.
And that's exactly where informed consent comes into play. Look, it's so much more than just signing a piece of paper. It's really about having a conversation. It's making sure you know exactly what you're getting into, the good and the bad, so you can make a real, rational choice that's right for you. So if you ever participate in a study, this is basically what you'll see on a consent form. It's all laid out there in black and white, exactly what you'll have to do, what the potential downsides or risks are, and, really importantly, how they promise to keep all your information safe and sound.
Now, what about those times when a study kind of needs an element of surprise to work? That's where deception can come in. But there are rules. There's what's called passive deception, which is basically leaving some information out, omitting the full story. And then there's active deception, where researchers might tell you something that's not quite true. Now, this stuff is used really, really carefully, and only when the potential discovery is huge and the risk of any harm is super low. And of course, your privacy is a really big deal. Confidentiality just means your data, your opinions, your results, your personal info is kept under lock and key. But on Anemone, that takes it a step further. It means your name and your data are never even connected. It's kind of like a digital witness protection program for your information.
You know, all these ethics aren't just about protecting participants. They're also about protecting the integrity of science itself. It's a fundamental promise to be honest and transparent in the work you're doing.
And when that promise is broken, you get research fraud. This is like the cardinal sin in science. When a researcher deliberately fakes or misrepresents their data, it's a huge betrayal of public trust, and it damages the entire scientific effort. It's not just bad science, it's an outright lie.
So how does the system catch this stuff? Well, science has this pretty cool three-part defense system. First, there's peer review, where other experts in the field act like detectives, checking the work before it gets published. Then there's replication, where other scientists try to do the exact same experiment to see if they get the same results. And finally, there's data sharing, which forces researchers to put all their cards on the table if asked.
So we've come a long, long way. We've definitely learned from the mistakes of the past. But the future? That's bringing a whole new set of challenges. I mean, with things like AI, gene editing, and massive data collection becoming common, the ethical questions are just going to get more and more complicated. The real question is, are our ethics ready to keep up?